Peace, mercy, and blessings of Allah be upon you. How are you guys doing? God willing, today is the second day or the second lecture of the course on reading and examining medium voltage switchgear diagrams. Yesterday, we took an introduction to voltage switchgear, drawing, and control systems. Yesterday, we took an introduction to electrical power network, and we understood the topic of generation, transmission, and distribution. We got to know all of them, and then we started talking about the different bus bar arrangements. We focused on the single bus, single breaker with sectionalizer and understood how its system works. We understood the concept of the bus bar and how to divide the sections and connect them through a bus tie, also known as a bus section or bus coupler. We agreed on how to connect them through either a dummy bus or through what. And we understood this story. We understood why it is used and for what purpose. So we focused on it. And then, of course, we talked about everything that is present, essentially starting from, in essence, the miniature circuit breaker, the auxiliary relay, or the contactor relay, or the contactor. Let's say we talked about the circuit breaker itself. We talked about the current transformer and the voltage transformer. And then in the end, we took how to read hours. It started to let us get to know our pages and let us recognize the first page that describes this. The second page we saw, which is and we understood what its purpose is. After that, we moved on then we entered the cells of mind, and we saw what is used inside ours, indicating what it means. So if I didn't understand something, I can easily refer back to it, God willing. The last circle present, or the last thing we have, I will leave it because your questions truly deserve to be answered first before we move on to another point, which is the circle. And then directly move on to the DC circuits. Okay, let's start. In the name of God, let's begin with the DC circuit. Now, engineers, regarding the AC circuit, which is the circuit related to the automating card, we currently have all the protection circuits and all the control circuits within power stations being operated through DC and not through AC. All right then, as I told you, engineers, now you have all the control circuits and all the control systems being operated through what? Through DC and not AC. Okay, let's take a look together. I'll draw something for you by hand. Let's see it together now. Engineers, the idea is very simple. In power stations, what happens is the following. What happens, engineer, is that one of the feeders of the switchgear, which has a voltage of 13.8, okay, you have a 13.8 cold bus. It starts to exit from here, from the bus. Of course, through the withdrawable circuit breaker that we mentioned, as we previously discussed, it exits here and exits from this point. In this setup, you have the air switch or the feeder air switch, commonly referred to as the feeder air switch. One of these feeders, engineer, exits here to something called the substation service transformer, the SST, which stands for the substation service transformer. This is the transformer that supplies the station services. It steps down from 13.8 kilovolts to give you 380 volts on the other side. You take this 380 volts, which is of course three-phase, and you connect it here, engineer, to an electrical breaker, specifically a low voltage circuit breaker. It will be fitted with a breaker, exactly as you said, it will be fitted with a breaker. This is how it becomes an incomer. And what does it connect to? To the bus. And you also have another substation service transformer that comes here and also connects to an incomer and then to another bus, right? So here you have two substation service transformers. For example, this is substation service transformer 2, and this is substation service transformer 1, right? And between these two, there is also a bus section. Great, guys, very good. From here, I exit with a set of MCCBs. Here, it could be an MCCB, all right? A set of MCCBs here like this, and a set of MCCBs here like this. In this manner, of course, this is an MCCB, as I explained to you, and this is a low voltage circuit breaker, and this is also a low voltage circuit breaker. This is a circuit breaker. This is a molded case circuit breaker, all right? So you have this part, engineer, this part here, we call it engineers. A CDB which is the main meaning the AC, which is the alternating current, which is the AC voltage, meaning distribution A panel, or it could be B like this, which is the distribution A board. All right, engineers, the history is very nice. So what do I start doing? I start taking, for example, a part, for instance, one of these like this, and I take it and go with it. Go with it until I reach, engineers, what? The switchgear room. So this is, for example, going to the switchgear. It comes here to the switchgear and enters what? It enters an incomer through an MCCB as well. And it exits from here with a set of MCBs, which are drawn like this and like this, a set of MCBs, which are miniature circuit breakers. It exits like this, in this manner. Of course, this is drawn like this and drawn like this, which is the symbol of the miniature circuit breaker. Okay, nice. But is it just one incomer? No, there could be an incomer and another incomer coming from the other section here. Okay, engineers. Okay, we call it an AC distribution board, but this is specific to the switchgear, for example, in a building. This is specifically for supplying the AC circuits located where in the switchgear, there is another one that might supply, for example, what you have in the GIS. Okay, another one might supply your protection panels, supplying them as they operate through any location you have in the station. All right, that's great. Now, regarding what you have in the station, keep in mind that I will return to this diagram when I enter, but for now, I will continue with our circuit. Okay, very good. All right, let me enlarge the camera on me. All right, so what's happening now, engineers and attendees? Now, what's happening for the upcoming engineers? What happens is that you take this line from your location, which is the miniature circuit breaker. This line from the miniature circuit breaker is one of those present in the switchgear, all right? And you connect it to a cell, which is the first cell in your switchgear. The first cell in your switchgear, okay? Very good. You connect it to the first cell, and it goes to this cell at X3, numbers 1 and 2. X3 is the rosette or terminal block. Numbers 1 and what number? And number 2. All right, very good. After that, you start connecting between the panels. What does that mean? You exit from X3, numbers 1 and 2, and you come here like this. You come, yes, you place a line here like this, and you bring a line here also on X3, also numbers 1 and what? 1 and 2. These two lines are AC, red and yellow. All right, oh, sorry, red and neutral. I mean, okay, single phase to ground. Of course, if you have 380 V as phase to phase, then single phase to ground was 230 volt as phase to phase. So single phase to ground was 230 volts. And just as you entered here, you exit again from here, from your line like this, all right? You entered it like this, you exit here like this, continue like this. And just as you entered here with your neutral, you exit like this and continue like this to the next cell. So you are standing here in the cell, for example, the one we are standing in, for instance, CH03 or H05, and what is its number? All right, you will start, for example, coming from building the cell before you, which is, for instance, numbered H03, and going to the next cell, regardless of what the number of that cell is. Here, the AC circuits are not very important to him, or the supply interruption to them is not very important, unlike the DC circuits, which I will show you why. Because the loads present on them as AC are not loads used in control. In switchgear as a breaker, or as RD, or as interlocking, nor is it controlled by protection circuits or anything at all. All right, very good. So this means that he exited from here with this MCB, with the red phase and neutral only. I mean, yes, you have this bus bar as 3-phase, but this MCB is 2-pole, guys. So let me enlarge this. Again.
Okay, so this bus bar is, of course, 3-phase. There's no debate about that. However, from these 3 phases, you only take the red and neutral wires and connect them to the miniature circuit breaker. This miniature circuit breaker is connected only to the red and neutral wires. You take these red and neutral wires, and here you have 2 fasteners. You then connect them to the first switchgear cell, which is supposed to be named H01, for example. Great. You then connect here to the terminal block, which is our junction box, for example, X3 numbers 1 and 2. After that, you exit from this same terminal block and go to the next cell, connecting again to terminal block X3 numbers 1 and 2. And then you exit Then you go to the next cell. For example, 805, 803, and so on. So what are you doing? You're creating a loop, exactly, creating a loop. And of course, the connection is parallel. What are you connecting? AC voltage for all the circuits you have. All right, great. Let's enlarge it a bit. Here we go. So what is this? It's the looping process. As you can see here, I came in here and then went out again to the next cell. So what do you have inside, engineer? You brought me here to the terminal block X3, here 1 and 2. Exactly. This is its diagram, engineers, if you look at it closely. Great. If you look closely at this TP diagram, if you go to the bill of materials page, you'll discover that this terminal block X3 is a slide link TP. Just a moment, look. Engineers, like this one here, this is called a slide link TP. So here, look here, there it is. All right, this link, as you can see, this end and that end are shorted together or touching each other. So if you connect a wire here and connect it, engineers, but those who come a bit late, just so we don't have to stop the explanation multiple times. Let's try, engineers, to stick to the schedule, please, so that there won't be any confusion for the people following along with us. Anyway, as you can see, engineer, between here and here, these two ends are connected together, as you can see. If you take this link and bring it here to the left, then these two will be separated from each other. Of course, this is not what you are talking about here, but I am telling you that this is an example. This is special, but I am telling you, this is specific to you, but I'm telling you. Do you understand the idea? All right. Here's another one, for example. I've brought it open here like this. What? From the inside, so you can see it. All right. So these two are connected together like this. If you take the screw here like this, you open the screw from here like this. All right. And push it to the side like this. Then you have opened these two, what? Apart from each other. So the wire here is isolated from the wire. What? Here, unlike this type, for example, from this type. What does fixed mean? It means here there is a single piece of copper or a single piece of aluminum. So the wire you connect here is the same wire that comes out from here. You have no problem at all. So these two are one piece. There is no concept of separating the two ends from each other. There is no concept, what concept of separating the two ends from each other. I hope this is clear now. This is what we call the fixed type. What is the fixed type? Okay, the standard, guys, around the whole world is that each terminal in a terminal block, any type of terminal block, cannot accommodate more than 2 wires. It's impossible. This has nothing to do with Skeko, Ranko, or whether it's in Egypt or outside of Egypt. It has no relation. Any terminal in a terminal block, for any type of terminal block, cannot accommodate more than how many? More than 2 wires. Nice. Very nice. So here you have, engineer, a slide link TP. So why, engineer Rashad, a slide link TP? Because here I can isolate the AC circuit without affecting anything. For example, if I want to do maintenance here, or if I'm changing the heater or the lamp that I'm working on here, I can isolate the TP. There might be any problem, you know. The idea is that I want to isolate the supply. I want to isolate the supply. So you can open it through the slide link TP and thus isolate the supply. The part before the supply and the part after, meaning you completely isolate here from the section below here. All right, very nice. So you came out here clearly. Since you will isolate without affecting your entire circuit, that's why when you came here, you exited from the same terminal. If you exited from the lower terminal here, of course, if you open this link, you will cut the supply to the rest of the cells after you. All right, I wanted to explain this part because people might ask about it. Okay, very nice. So you exited from the terminal block. What does the terminal block do, engineer? First of all, what is the purpose of the terminal block? What does the terminal block do, engineers? The first thing is that it makes measurement operations easier for you. Instead of going to the miniature circuit breaker itself or going to the contactor itself, let me also show you the example of the contactor. So instead of having moments where you bring a connector like this and you are the only one with this connector installed in your cell, and for example, it's full of wires and you want to connect to the terminal here or want to connect to the terminal here, or like the miniature circuit breaker, the small electrical switch like the one you have in your apartment, for example. All right, you want to connect the terminals here, so the matter is correct. You will always find that the termination must be on a terminal block. to make measurement operations easier for you and also to facilitate troubleshooting. Or, the idea that you have divided the circuit into more parts. All right, great. So I exit from the TBD and enter into what? I enter into a miniature circuit breaker. This is called a miniature circuit breaker, which is what? It's this, all right? This is its symbol. So how did you know, Engineer Rashad, that this is its symbol? It's very simple. What did we agree to do? We agreed to refer back to the legend we have here. Isn't that right? So where is this legend? Where is the drawing you saw a while ago? Let's, for example, look here and search for it, maybe here. I think it's on the previous page. Here it is, Engineer Abbas. This is the symbol that was present. It indicates that it is a miniature circuit breaker, and it takes the symbol B or whatever according to your drawing. So, as you can see, it indeed takes the symbol B, and this is the shape of the miniature circuit breaker. Of course, I brought you a single pole one, and there is another that is a double pole. So what is drawn in front of you here is a double pole. Very good, okay? Here, it brought you the subline AC, all right? Let's go from the easiest to the hardest. Now, you took the subline AC and followed it to the end of the circuit. At the end of the circuit, there is a lamp here, right? But if you don't know, you can also go to the list of symbols to see what this symbol represents. All right, and here before it, there's something called LSTO. Who is LSTO? You'll find in the schematic that it marks LSTO with a star symbol and writes LSTO here on the side. Here's the schematic itself as a PDF. Of course, I will cut it out from the schematic here. All right, here's the LSTO in the same drawing that I cut from the schematic. You'll find I've written here what? Here it is, LSTO note. As long as I put a mark next to it here, it means I've written a note here, and I'll tell you what it means. All right, great. I'll cut this out and put it in the presentation so I can move through it comfortably. Of course, here it is. So it says LS2, which is when the panel door is open. LS2, my friend, is a limit switch, like the limit switch on a refrigerator door, a car door, or whatever. It's the end of stroke switch, which we refer to as the end of stroke switch. This switch, it says, is closed. As you can see here, or in its diagram, DLS2, it shows you here when the door is open, any door, which is the voltage compartment, the upper part of the cell where your control circuits are located. This means that as soon as I open the door, this contact will be closed. So what do I gain from this? I gain that the supply will come like this, and the supply reaches here like this. Of course, the neutral goes to the lamp, and it needs the live. When you open the door, this contact is closed, allowing the supply to pass here, so the lamp lights up. This way, the maintenance person can look inside your panel and start working, whether it's troubleshooting or cleaning or whatever task they are doing, whether it was maintenance or whatever. Okay, great. So this is the first circuit. Now the second circuit, I have the supply coming here, entering our circuit with the live and entering our circuit with the neutral into something called THH. So what is THH? It's a thermostat. This is a type of thermostat or humidity switch, meaning it works as a thermostat, or humidity state, which monitors the humidity level. Okay, very good. So it also passes through here. The AC enters a device, and this device takes the power supply. Very good. Then it comes here and passes through, or also your live wire from here and here. So what is the difference between these two? Look, sir, this is a switch for changing modes. Do you want it in one mode or another mode or another mode? Okay, so the mode that is closed is the one in use. The auto mode is the one that is closed. In manual mode, this is the one that is closed. In the off mode, both are open. Okay, so both are open. Now, if I choose manual mode, this will close and that will be open. So the supply will come down here and go to something called the heater, which will operate continuously to heat inside the low voltage compartment. This is to prevent any moisture or anything from causing a short circuit on the control circuits. Okay, Engineer Rashad, if I am in auto mode, if you are in auto mode, erase this. All right, and you will find that this is the one that is closed. When this closes, the supply will come from here, pass through the heater, which is connected to the neutral from here, and it needs the live. Of course, this is open. So the live comes down here. Yes, it comes down to pass through and go here. This contact must be closed. Which contact is this? As you can see, this triangle symbol is a comparator symbol. A comparator means something that compares temperatures. So depending on how you set your thermostat, to a certain temperature, like the one you have in the heater or the one in the air conditioner, it measures the temperature. Based on the temperature setting you have, if the temperature is lower than that, it automatically closes this contact. Then the supply goes from here to the heater. So the heater starts working and begins to heat up until the temperature inside the cell reaches the point where the thermostat senses it. Then what does it start to do? It starts to open this contact again, which turns off the heater. As for the manual or engineer Rashad, the heater was always on and nothing was sensing the temperature. Of course, it's called manual because you have full control over it. You have complete control over the heater, okay? And that's simply how it got its name without any other issues.